Today we'll be having a look at the unit circle as well as radians, and this will let you have a deep understanding of trigonometry. We'll start off with the unit circle, which is a very important concept that allows us to see how sine, cos and tan relate to our angles. It's called the unit circle because it has a radius of 1. You read angles anti-clockwise, so you can see how here we have 45 degrees. You can also read angles by going clockwise, but this makes your angle negative. Now I'll show you what radians are. Radians are a different unit of measurement for angles, and you can use them instead of degrees. They become more useful when you study higher levels of maths. And what they physically are is the perimeter or the circumference of the circle that the angle covers. So you can see that length S. That physical length is our radians that corresponds with 45 degrees. Now I'll show you how to work out radians. So since radians are the distance of the perimeter of the circle that the angle covers, let's start with 360 degrees, which would be the entire circle. So how do you find the perimeter or the circumference of a circle? Well, that's going to be equal to 2 pi r. Now we know that our radius is 1 because this is the unit circle. So that means our perimeter is going to be equal to 2 pi times 1, which is 2 pi. And this gets us our first radian of 360 degrees being the same as 2 pi radians. So 2 pi is the physical length around this entire circle. Now what about 45 degrees? Well, we can figure it out like this. If the entire circle is 2 pi radians, how much is half? Well, that's going to be half of this. So 180 degrees is the same as pi. I've just divided this by 2. So if this is pi, then how much is half of that? Well, 90 degrees is pi divided by 2. So this would be pi on 2 radians. And then if you divide that one more time by 2, that will get us what our 45 is. So 45 degrees is equal to pi on 4. So this length right here is pi on 4. So that means 45 degrees is the same thing as pi on 4 radians. An easy way to convert between degrees and radians is like this. So you get 45 degrees and you times it by pi on 180 degrees. This will cancel out our degree units and it will let you work out what the radian is. If you wanted to convert radians into degrees, well then you multiply your radians by 180 degrees over pi. So you can see how basically whichever unit you have, so in this case degrees, that is what goes on the bottom. And then the top is what you want to get to. So you can see here how we start with radians. So we start with our radians on the bottom and you want to get to degrees. So if you multiply this and worked it out, you would see that this is equal to 45 degrees. When you cancel these out, 180 divided by 4 is 45. Let's have a look at what radians physically are one more time. So we can see that 2 pi or 360 degrees is the length around the entire circle. Then pi is the length around half the circle. Knowing that pi is 180 degrees is very important because it helps us to figure out something like this, where 180 divided by 2 gives us 90. Then 180 divided by 3 gives us 60. And you can do this with the other angles as well. So you can see how these angles correspond to the physical length on the perimeter of the circle. Radians become even easier when we think of pi, so 180 degrees, as half of our circle, and we think of it like a physical cake that we can split into slices. So look at pi on 2. It says cut our pi into 2 slices. You can also think of this for pi on 3, so 3 equal slices. You can see how each slice is 60 degrees. Then pi on 4 for 4 equal slices, and even pi on 6 for 6 equal slices. Now that we know what radians are, I'm going to show you how sine, cos and tan relate to our unit circle. So I'm sure everyone was introduced to trigonometry using SOHCAHTOA. And I'm going to show you how those definitions relate to this unit circle as well. So if we have this triangle and we put it here, we can find sine. So we know sine is equal to opposite divided by hypotenuse. So our opposite is this length here. And you can see how that length here corresponds to our y value at that point. So that is our y value at that point. To find sine of theta, we can do our opposite length, which we said was our y value, divided by hypotenuse, which we know is 1 because this is the unit circle, and it has a radius of 1. So that leaves sine of theta is equal to our y value. This is a very important concept to understand. So any point on this unit circle, if you draw a line up like this and you have an angle here, whatever the y value there is what sine of theta is equal to. Next, we can find cos of theta. And that's going to be adjacent, which is our x length there, or our x value at that point. And we can find it by doing adjacent, which is x over hypotenuse, which is 1. So this leaves us with our cos of theta is equal to x. And this is a very, very important concept as well. And finally, tan is equal to opposite divided by adjacent. So we found that our opposite was that length there, which is y. So tan of theta is equal to our opposite divided by our adjacent length, which is x. So what does this show? This shows that tan of theta is equal to sine of theta divided by cos of theta. So these are very important points to understand. To make sure that you really understand that sine of theta is our y value, cos of theta is our x value, and tan of theta is our y divided by our x value, I'm going to do some examples. So imagine that we have this angle here. That angle is pi on 2, or 90 degrees. So if I asked you, what is sine of pi on 2, or sine of 90 degrees, I'm asking you, what is the y value at that point? And since this is on our normal axis, and it's a unit circle with a radius of 1, the coordinate there is going to be 0, 1. So looking at that is very easy. Our y coordinate is 1. So sine of pi on 2 is equal to 1. What about cos of pi on 2? Well, cos of pi on 2 is our x coordinate at that point. And we can see it's 0. So that's 0. Now, tan of theta is equal to our y coordinate divided by our x coordinate. Well, what's our y coordinate there? 1. And what's our x coordinate there? 0. You can't divide by 0. So what that means is tan of pi on 2 is equal to being undefined. Okay, let's do another example. So imagine instead of pi on 2, or 90 degrees, we had this. We had 180 degrees, or pi, radians. Well, looking there, what's our coordinate? Our coordinate is -1, 0. So what does that mean? Well, sine of pi is going to be equal to the y coordinate there, 0. What about cos of pi? Well, looking at that, our x coordinate is -1. And then finally, tan of theta, tan of pi, is our y coordinate, which is 0, divided by our x coordinate. What's 0 divided by -1? Well, it's 0. So tan of pi is equal to 0. So I hope you can see how when you get a particular angle and you draw that line to join up with the circle, whatever that coordinate is is related to your sine, cos, and tan values. So I know I used easy examples for these questions here, but you can go ahead and pick different angles, such as 45 degrees. Now the problem with this is it's a bit of a hard coordinate to read. You don't know exactly what that x value is because this is 1, but what's that? It looks like 0.7 something. And that is what the answer would be. The answer would be root 2 over 2 for cos of 45 or cos of pi on 2. Sine in that same spot is the same value. It looks like 0.7 something as well. So you can see how sine of 45 degrees and cos of 45 degrees will get you the same answer because they have the same x and y coordinate in that location. So I showed you what sine of theta is physically. It's this length here. Then I showed you what cos of theta is. It's this length here. What about tan of theta? This is just for a bit of extension, just for completeness. So if you look here, we have this line that just touches our circle at this point here. That kind of line is called a tangent. So any line that just touches a curve at one point is called a tangent. And that's why this is called tangent. What we can do is we can extend this line out until it touches that tangent line. And when we do that, the y value at that point, so as you can see here, the y value at that point, so this entire length, is our tan of theta. So in this case, the angle that we have is pi on 4, or 45 degrees. So that means tan of pi on 4 is equal to 1. And if you pick another angle, you can see how the value of tan will get very, very, very big as that angle gets higher up because it takes a longer time until it hits this red line. So you can imagine that red line is continuing all the way up. Just to summarize everything visually, you can see how sine, cos, and tan change as theta changes. So pay close attention to that coordinate as I make our angle bigger. You can see how as I make the angle bigger, tan gets bigger, our cos gets smaller because our x value is getting smaller, and our sine gets bigger because our y value is getting bigger. Now you might be thinking, okay, it's all easy if the angle's 90 degrees, and they ask me what cos of 90 degrees is. Well, that's 0 because the x value there is 0. But what if they give you an angle that's not at one of these nice spots? What if they give you something like 30 degrees? How are you going to know what the x value there is to figure out cos of that angle? Well, there are a couple of important angles that you need to know the coordinates of so that way you can figure out sine, cos, and tan. And those are these angles. So first I'll start off with pi on 4 or 45 degrees. This has the coordinate root 2 over 2, root 2 over 2. Next, I'll go over to pi on 6, or 30 degrees. This has a coordinate of root 3 over 2 and a half. And then finally, I'll go over to pi over 3, or 60 degrees. This has a coordinate of a half, root 3 over 2. Once you memorize these, you can solve questions like this. If they ever asked you, what's cos of pi on 3? Well, if you know the x coordinate there, you can immediately say a half. Or if they asked you, what is tan of pi on 4? If you know the coordinate here and here, you know that it's y divided by x. And what's root 2 divided by root 2? Well, it's the same number divided by the same number, so it's 1. So you can see how useful this can be. Pause the video and try these examples here. So, starting with the first one, sine of pi on 3 means that we go to pi on 3 and we look at the y value. Well, the y value there is root 3 on 2. So the answer here is root 3 on 2. Cos of pi on 4 means that we look at the x value over here. So that's pi on 4. And then tan of pi on 6 means that we just get the y value here, and then we divide it by the x value. So I hope you remember that when you divide fractions, you can multiply them and flip the other one. This cancels with that, and you're left with 1 on root 3. Now you might be saying, okay, well, these angles are all good, I've memorized them, but do I have to memorize every single angle around the rest of the unit circle? Well, the answer is no. So for these very important ones, you can use symmetry across the circle to get the answers there as well. But before we go on, I need to tell you what we call the other parts of the unit circle. So this is the first quadrant, this is the second quadrant, this is the third quadrant, and this is the fourth quadrant. So if we look at the second quadrant, we can mirror this exact image of the first quadrant over there. So you can see how symmetrically I can draw this. And what that means is, if they ever gave you something like sine of 2 pi on 3, 2 pi on 3 is the same as 2 times this, or 2 times this, which is 120. All you do is look here, and you say, wait a minute, the y value there is the same as that one. So that means this should also be root 3 on 2. So understanding this symmetry is very, very crucial to being able to solve these questions when they give you different types of angles in other quadrants. Now I'll show you how to handle questions like this, where they give you an angle in a different quadrant. So first off, you might say, well, how am I going to find what that is? Do I have to convert that into degrees and then find it? That's going to take a long time. Well, you don't have to do that at all. What you need to see is the base angle is pi on 6. So memorizing this part will be very useful. Now that we know it's pi on 6 as our base angle, I hope you remember that I said that pi can be thought of like half of the circle as a cake. And we're cutting it up into 6 slices. So you can see that's what I've done here. Now, this angle is in the third quadrant. And even if you don't know that straight away, I'll show you how cutting up the rest of the circle as well into equal slices can help you figure out easily where this angle is. So let me just cut the bottom into 6 slices as well. So now that we've done that, all 7 pi on 6 means is 7 slices. So 1, 2, 3, 4, 5, 6, 7. Now we know where that angle is. So this angle would be 7 pi on 6. Now this original base coordinate that we memorized is over here. So I'll copy it down as well, and I'll show you why it's very useful. So this question is asking us sine of 7 pi on 6, and I hope you remember that sine is our y value. So looking at this, our y value is a half. And looking at this, by symmetry, that length there, the actual length should be a half as well. But since it's on the bottom, it's a negative half. Negative half. So our answer here is negative 1/2. Now if they asked you, what about cos of 7 pi on 6? Well, you'll just look at this. You know it's root 3 on 2. So this length here is root 3 on 2. By symmetry, this length there should be also root 3 on 2, but it's on the left-hand side. So that is negative root 3 over 2. So I hope you can see how the coordinate of this point over here will be this. We can do the exact same thing with pi on 4 as well. So imagine they gave us a question like this. all we do is divide our pi into 4. So you can see how I've broken up into 4 slices, and I can do that for the bottom as well. So once I do that at the bottom, all I need to do is count 7 slices. So 1, 2, 3, 4, 5, 6, 7. So that's our location. That angle there is 7 pi and 4. Now I'm going to copy down our base angle from up here and the coordinate as well, just so you can see how it relates. Now, sine of 7 pi and 4 is asking us what is the y value here. Well, by symmetry, we can see that the y value here is root 2 on 2. Since this is down, it's going to be negative root 2 on 2. And finally, we can do the same thing with pi on 3 as well. So we cut our pi up into 3 equal slices, and I can do that at the bottom as well. So now, when we get a question like this, we can easily solve it. So all we need to do is count 4 slices. So 1, 2, 3, 4. So this angle here is 4 pi on 3. And it's asking us what is the x value there. So if we memorized our base angle, the coordinates for our base angle here, we know that the x value there is a half. So by symmetry, if this is a half, then this has to be negative a half. So our answer is negative a half. To solve something like this, again, it's important to know what our base angle is, so pi on 6, so it's important to know this coordinate pair here. Now once we know that that's our base angle, we can just count 13 slices and see where our position is. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. You can see how it lands us back in our starting point. So what does that mean? That means our question here is the same thing as tan of pi on 6. They both equal the same number. So all we need to do is work out tan of this, and we get our answer. Well, remember tan is sine divided by cos. So sine would be our y value there, and cos would be our x value there. And once we have that, we can just work out this as 1/2 times the flipped fraction on the bottom, and that gets us this cancelling, so 1 on root 3. You can either work this out every time that you need tan, or you can just memorize the tan that's associated with each coordinate as well. Now, this question here gave us the exact same tan value as our base angle. But what if they gave us something like this? What if they gave us tan of, let's say, 5 pi on 6? Well, what do you do then? Well, we know our tan value on our base angle is now 1 on root 3, because we just worked it out here. So all we need to do is find the position of this. So it says 5 slices, so we count 5. 1, 2, 3, 4, 5, and that's where it lands us. And it lands us here. And we know the coordinate there is just going to be the negative of this and the same y value. So it's that. Since it's the same numbers dividing by each other to work out tan there, so 1/2 divided by negative root 3 over 2, but now one of them is negative, that just makes our answer negative. So you can see how the answer to this is that. So it's very important to know which coordinate is positive, which coordinate is negative, to know if tan is positive or negative. So for example, looking at the third quadrant, here you can see how our y values are negative and our x values are negative. So if we do sine divided by cos, that would be a negative y value divided by a negative x value. So overall, the negatives would cancel and tan would be positive in this third quadrant here. Here is a summary of all of the exact values that you should know from the first quadrant. The easiest way to memorize this is just look at this and then try to draw it on another piece of paper and then look at what you've missed and repeat that until you get it right. So it's also easy to see that these are the same values, and then if you memorize just this one, you flip it for this one. I've also written the tan values as well. You can work those out when you need them by dividing sine and cos, or you can just memorize the values and that makes it a bit faster as well. I hope that makes sense, and in the next video I'll explain to you how to sketch sine, cos and tan graphs.